Okay, so our next example we're going to go over is our combustion examples. If you watch Jeff's slides, you'll notice that he talks about oxygen limited combustion and what that is. We've got, I think I'm going to start I'm going to start here. Okay, so this is basic fire. I've got some points that I'm initializing attributes on: fuel and temperature, creating velocity, adding some noise to fuel and temperature, and turn this off. Let's see what we got here. Okay, they're not animated or anything. I think velocity is animated. Yeah, okay. So we got animated velocity and noise on fuel and temperature, and then rasterizing that and plugging it into the solver. Okay, so why are we doing this? A couple important things that I just want to bring up. Don't need fire. We just need temperature and fuel. We have velocity because we're sourcing it, but it doesn't need it to work. What I wanted to do is show you that we've got our solver can just, like, even though it's got these evaporation bells and whistles and collision erosion stuff, like, we can just still create simple fire. And this didn't take long. Like, this didn't take long at all to build. You can create fire that doesn't look too bad. This is just a viewport and all that jazz, but it doesn't look too bad. And our solver can do what a sparse pyrosolver does. The like addition is that we're using oxygen limited combustion. We haven't gone over that tab yet, but it's right next to evaporation. And not a lot of controls here, which is, I think, a good thing, but yeah, we control it in this combustion tab. A quick note is, in this fields tab, we've got additional dissipation controls. This defaults to 0.1, but this is important for oxygen limited combustion because oxygen equals 1 minus fuel minus waste minus water for right now. So we can have oxygen limited combustion, manual mode. We can have oxygen limited combustion up here because we only have fuel here. So there's the, and waste is getting out of the way, I think. Can visualize it. So this could be like treated as a soot field, or you can use this to you can use this field however you like. So yeah. I have another oxygen limited combustion model here, and this one is the purpose of this one is just to say, hey, just to prove to you that oxygen limited combustion is working. So we've got two fields, temperature and fuel. Those are two of the requirements for the oxygen limited combustion. Fuel is big. Temperature is inside the big fuel. Got no buoyancy, no velocity. Not sourcing fire. Just have temperature, fuel, and activation of velocity 0. So we're only sourcing fuel and temperature. No shape operators. Turned off dissipation for waste and fuel, just so they don't ever leave. And yeah, buoyancy scale and temperature diffusion is 0. And these are all default. Everything in here is default. Okay, so what does that give us? It doesn't give us any waste. You can see here in the geometry spreadsheet, there's no waste happening, so nothing's burning. Fuel stays constant at 1, I think, because we're sourcing it. The operation is set to maximum. And then temperature, I think because of this blur, which shouldn't have to mess with, because of the blur. It is just like kind of easing its way out. But because temperature is inside fuel, there's no combustion occurring. Oxygen is 0. The fuel requirement and temperature requirement have been met. But because fuel is 1, the oxygen requirement has not been met, so no combustion occurs. Kind of a weird example, but I just wanted to show it. Okay. Last, I want to go over the parameters themselves. We've got fuel and temperature, both equal to 1. Temperature is inside fuel, just like this is like acts as an ignition point, adding velocity and a bit of noise. We'll check sourcing. Got fuel, temperature, fire activation is 0 because we don't need it, and combustion settings are default. So that gives us, because I've highlighted that. Okay, so we've got combustion. We can visualize fuel. We can see that it's being injected into the sim, and that values are changing. And we've got temperature, just as default settings. This is here for a comparison. The next sim is burn multiplier example, which is the first parameter. Okay, what is burn multiplier? So when combustion occurs, this controls how much fuel is removed from the voxel. So burnt fuel times this is removed from each voxel, each time step. So what does that give us? This is 10% of the default value. Set it to auto update. And like we're not getting as much reds in the temperature field, so like things aren't getting as hot. At least until later. Like the reds are coming up later, whereas if we look at this, reds are happening earlier. Things are getting more fuel is getting removed each like time step, and yeah, more burning is happening. So here we have like temperature living longer. More stuff is burning up here. We can also visualize fuel, saying that like, oh, there's more fuel happening, like more fuel is getting burnt up here. So decreasing burn multiplier is like, hey, we're going to remove less fuel from the sim at each time step, which you know, in this case results in like more burning happening higher up. Fuel's living longer. Okay, last parameter. We're going to skip ignition temp because the help note is pretty self-explanatory. If temp is below this threshold, no combustion occurs. So we'll jump to temp gain. So what is temp gain? Temp gain, this parameter is this parameter times amount of burnt fuel is added to temperature each time step. So what does that mean? Like, things are going to get hotter. We can see that in this geometry spreadsheet. If we compare the two, we look at this one, it's like 1.5, 1.9 at the highest. This one is 1.6 to 1.8, but this one's 5. So things are getting much hotter. Okay, so how does that impact the sim? Well, we look at all of them. This is temp gain of 5, this is burn multiplier of 0.5, and this is default. It's getting much hotter. We can see way more red. It's rising faster because it's got higher temperature, so buoyancy is much higher. Or maybe it's the same. Maybe buoyancy is the same. It doesn't look like it. Oh, that's probably, yeah. I think buoyancy is higher here because it. Yeah, it is. It is. Okay. Because temperature is higher, the condition, there's like a greater probability of the conditions for ignition temp to occur, which means like that's why, oh shoot, so that's why this fuel is smaller than like the default settings fuel. What am I looking at? Yeah, okay, so that's why, yeah, that's why these this fuel is smaller than the default settings fuel. There's just more opportunity for the ignition temp condition to be met. Yeah, that's it. I've got some help notes over here as well. Yeah, that's it. Hopefully this helps like, this is a simple example of what the settings do with no shaper operators and nothing else influencing it, and hopefully it helps you get a better understanding of oxygen limited combustion. And if that's not good enough, go check out Jeff Late's tutorial, because it's pretty good information. Thanks. I guess we'll see you in the next one.